So prior to doing any actual research for this assignment, the only projection map of the Earth that I could actually recall the name of was the Mercator projection. This is a projection of the spherical Earth onto a plane first made by a Flemish cartographer in 1569, named Gerardus Mercator. It is also a projection that was very common in schools and textbooks for many years, despite the fact that it is seen as mostly inferior projection for students studying basic geography. It is deemed inferior due to the fact that it does not preserve distances or areas, although it does maintain angles, which is something we'll touch on later. I forgot what the name of the actual theorem was that I was researching, but it's attributed to Gauss and says that any spherical projection onto a plane will always distort something. Whether it is angles, areas, or distances, you cannot save them all in the same projection. So back to the Mercator projection. As you can see, the Mercator projection can lend itself to instilling some major inaccuracies regarding the layout of our planet. I recall sitting in school and looking at Greenland in particular, and thinking that it must be some massive winter wonderland the size of Africa or South America, but rather in reality, I should say, it's only the size of the Arabian Peninsula or a little smaller, which is something you wouldn't think from the way this map is portrayed. Another inaccuracy is the way Antarctica and the land masses near the North Pole are portrayed, because down here they're technically shoot off to infinity, the areas and distances of Antarctica and the North Pole, which is something, or which comes as a result of the way the projection is made. But you might ask yourself, if it's so inaccurate, why would you ever want to make it or even use it for for any purpose? Well, you kind of have to put yourself in the time that this map was first made. Maps of the world at this time were mostly used aboard ships making some of the first ultra-long distance journeys. So journeys that were, some of the first transatlantic journeys, or the first circumnavigation journeys around the globe. And if you're a sailor in the 16th century and you want a map aboard your ship, you want one that preserves angles above anything else. Because a map that preserves angles, such as the Mercator projection, will allow you to draw just straight lines between 2 points to chart your course. So if you're in England and you want to get to the Caribbean, all you have to do is draw a straight line from England to the Caribbean, and then you've plotted your course, something that can be done with ease and something that you would want as a sailor. But how is this projection made? Well, if we get a couple props here, and if we take this golf ball to be the spherical Earth, and we take this post-it note here to be the plane on which we will project our image of the Earth, and we also imagine, or to further visualize the Mercator projection, how it's made, we can imagine placing our plane on the sphere in such a way that it wraps around the sphere, touching only those points which are on the equator. To further go along, using our imagination, if we imagine a light source coming from here, projecting this way towards the plane, visualizing this projection, you can see that the points on the equator will be mapped accurately without distortion onto the plane, because that's the only place that this plane is actually touching the sphere, is at those points on the equator. So everything is accurate at the equator. But as we move away from the equator along the meridian lines, the distortions increase and move away in both north and southerly directions. This will happen. And this is because the sphere is curving away from the plane, yielding stretched out distances which are elongated due to the fact that the meridian lines on the globe will eventually intersect, while the meridian lines on the projective plane do not. They will always be parallel, and that's something you can see very nicely in the background image there. So causing Greenland to look as large as South America and the areas closest to the poles to be sent to infinity. The exact north and south poles will actually be at infinity. And I think this kind of summarizes, hopefully, the way the Mercator projection is created.